Hello, I am coming to you today with some more problems from lesson 7, picking up where we left off last Thursday in class. I want to supplement our class time with a video today where I'm going to finish up lesson 7, and then look at problems in lesson 8, again, to make up for some lost class time or whatever the case may be. I will be sharing my screen so that you can see what I'm going to be working through. And I'm zooming in here. So again, these problems come from lesson 7, the first one here, and I'm going to move the problems underneath that so that those are a little clearer. All right, so this first question or first problem from lesson 7, where we picked up last time, is dealing with direct variation. So it says, suppose that y varies directly with x and y equals 4 when x equals 16. Part A says write a direct variation equation that relates x and y. So a direct variation equation would be of the form, I'm going to jot this down, equation of the form y equals k times x. And this is where k is some arbitrary constant, where y is equal to x times that constant k. That is direct variation, okay? So k is, again, some arbitrary constant that we have to find. And then once we have k, then we'll have our equation, y equals some number x, okay? Now, to get k, we are um, oh, right here, we are given that y equals 4 when x equals 16. So given y equals 4 when x is 16, we're going to use that to actually find, we're going to substitute those values in to find k. So we've got y equals k times x. So we'll have 4 equals k times 16. Okay? Again, replacing y with 4 and x with 16. And then solving that for k, we would divide by 16, and that would give us k equals 4 divided by 16, or 4 over 16. That reduces to 1/4. Okay? So our equation then, our final equation is y equals 1/4 x. Okay? Y equals 1/4 x. Now, what we're going to do is then use that formula or that equation to find what y would be when we let x be 3. So using y equals 1/4 x, we're going to replace x with 3 to get the value of y. When x is 3, y is 1/4 times 3, which is 3/4. Okay? That is direct variation. Pretty straightforward. Again, one thing you just want to make sure you're aware of, that this is the form for direct variation, because we're going to look at an inverse variation. Okay. The next one here says write an inverse variation equation. It says suppose y varies inversely with x and y equals 5/2, 5/2, when x equals 8. Okay? So when this is the case, we have the equation for inverse variation. It is y equals k over x. So it's y is equal to a ratio of k over x when it's inverse. And when it's direct, it's y equals k times x. Okay, but inverse is y equals k over x, or k divided by x. All right, and now to get k, just like we did before, we're going to use the fact that they gave us y is equal to 5/2 when x is equal to 8. So we're going to first find k using when x is 8, y is 5/2. So we'll have 5/2 equals k over 8. Okay. Now, of course, you've got your calculator, but to solve this for k, we need to undo that divided 8, which means we have to multiply by 8 on both sides there. It cancels there. 2 will divide into 8. Okay, we can actually reduce that, or you can just whip that right on in the calculator. 8 times 5 over 2, you can put that right in. 8 times 5/2, just like that. And you'll get 20 because 2 goes into 8 4 times, and then 4 times 5 is 20. So k is 20. So our equation is y equals 20 divided by x. Okay? We had to get the k first. Now that we have k, we can use that now, our given equation, or our equation that we wrote, we can now find what y is equal to when we let x be 10. So using y equals 20 over x, we're going to solve for y by replacing x with 10. And that means y equals 20 divided by 10. So y is equal to 2. Okay, so part A, we wrote the equation, and then part B, we used that equation to find a particular value of y when we let x be 10. Okay, and then there's one more problem related to inverse variation. It's a word problem. We'll look at that one. Okay, just make sure we're good there. So again, I would jot down, or I would have in my notes, the general equation for inverse variation, y equals k over x, and the general equation for direct variation, y equals k times x. Okay, here's a word problem, and I went ahead and wrote it out, of course, to kind of save some time here, but it says, this is a word problem on inverse variation. It says when a constant force acts upon an object, the acceleration of the object varies inversely to its mass. So acceleration varies inversely to mass. So one of the first thing I'm going to write is I'm going to let acceleration be A. I'm going to let that be A, and I'm going to let mass be represented by M. So acceleration varies varies inversely with mass. That means A equals K over M. Okay, K being an arbitrary constant. All right, this is A varies inversely to mass. Okay. Now, we are given that an object, let's finish reading. It says, when a certain constant force acts upon an object with a mass of 19 kilograms, the acceleration of the object is 4 meters per second squared. Then it says, if the same force acts upon another object whose mass is 2 kilograms, what will be that object's acceleration? So the first thing we're going to use is that we're given that an object with a mass of 19 kilograms has an acceleration of 4. Okay, so we're going to use that. Use m equals 19. That's the mass. And a equals 4. That's the acceleration of that object to first find k. Because remember, we've got to find our arbitrary constant. So we're going to say, using this equation, box it off here, using this formula or this equation, we're going to have 4, because our acceleration is 4. K is our unknown constant that we're going to find. And then our mass is 19. I don't know why I put another equals there. That shouldn't have been there. Okay, so given m is 19 and a is 4, we're going to find k. All right, so that means we're going to multiply each side by 19 to get k by itself. So k equals 19 times 4, which is 76. Then our equation is a equals 76 over m. Okay. Now it says if the same force acts upon another object whose mass is 2 kilograms, what is that object's acceleration? So now find acceleration of an object with M equaling 2, with a mass of 2. So we're going to say A equals 76 divided by 2. And to get that answer, 76 divided by 2, we get 38. So with an object that has a mass of 2 kilograms, the acceleration is 38 meters per second squared. Okay? So the last couple of problems there were related to variation. And then there's one more problem that kind of takes a turn that's a bit different than the rest because it kind of guides us or heads us into lesson 8. And that is this example right here. Okay? So again, this is the last problem in lesson 7. It is square root of a rational perfect square. So basically, you got the square root of a rational number. Rational is just another name for a fraction, okay? So you've got the square root of 36 over 49. What you can do is actually give top and bottom, numerator and denominator, its own radical symbol. So the square root of 36 over 49 can become the square root of 36 divided by the square root of 49. That way you can work with top and bottom individually because it's possible that won't divide evenly. Okay, so now perfect square, perfect square. So the square root of 36, you ask yourself, or you just use your calculator, either way, but you ask yourself what number when you square it gives you 36, and that would be 6. So the square root of 36 is 6. You still got your fraction bar, and the square root of 49 is 7. Both were perfect squares, so both simplify to just be whole numbers. And again, if you ever don't remember the perfect squares, you have your calculator, okay? So square root of 36 and then square root of 49, okay? And then 6 over 7 will not reduce any further, so that is your final answer there, all right? And that leads us into now lesson 8. That is the end of lesson 7. And lesson 8 actually kicks us off with some graphing. So I'll need a little bit of paper, but for the most part, I'm going to be pulling up the actual problem from Alex from the computer. So let me show that. And I may have to stop sharing for a second and then reshare to change my screen. So let's select a tab here, what I want to show. Here we are. Okay, I want to be sure. Let me stop sharing once more and then share again to ensure that it is showing the right tab. Here we are. So this particular problem, the first one in lesson 8, is saying find the x and y intercepts given the graph of a line on the grid. So with this one, I really just have to show you on the computer with the ones that are involving graphing. So the x-intercept is simply the point where the line, where the graph crosses the x-axis. And if you notice here, it crosses at 1, on the x-axis at 1. So the x-intercept, and if they want us to just give it as a single value, you would just enter 1. If they want it as an ordered pair, then you would enter 0, 1, but they'll let you know. They will tell you specifically. On this one, we're just entering the value, okay? And so the y-intercept is where it crosses the y-axis, and that is down here at -4, okay? So remember, on the x-axis, to the left is negative, to the right is positive. The origin is right there in the middle where the x and y-axis intersect, okay? And then the y-axis above is positive, below is negative. So it crosses it crosses the y-axis at -4, okay? So that's what you would enter there. And we can verify that by looking at the explanation, because again, Sometimes they want us to show it as an ordered pair. You see how it says right here, the line intersects the y-axis at the point 0, -4. So the y-intercept, we just put in -4. And the y and the x-intercept, 1, 0. So we just put in 1, okay? All right, let's move on to the next problem. And again, when I don't have to graph, I can actually write it, show it on the screen, but these involving graphing, I kind of need to. Actually, this one doesn't involve graphing. This one I'm going to actually do by hand. It is find x and y intercept. And the equation is 2x plus 4y equals a -12. Okay, so I'm going to stop sharing that. This thing with the computer, I have to go back and forth, so bear with me. Okay, so when I do have to graph, I'll go to those specifically. For the most part, though, these problems I'll be able to write. This one, it says find the x and y intercepts. And this is 2x, the line is 2x plus 4y equals a -12. So let's say we get the x-intercept first. So to get the x-intercept, we have to let y equal 0, okay? So the x-intercept is where we let y equal 0. So we're going to take that same equation, but where we have y, we're replacing it with 0. So we've got 2x plus 4 times 0 equals a -12. Okay, sorry if it's a little blurry. It's clear now. This becomes just 0 here. So 2x plus 0 equals a -12. So 2x equals a -12. And then when you divide by 2, x equals a -6. So this is the ordered pair 0, -6. I'm sorry, x is first. This is -6, 0. So your x-intercept in this case is just -6. Okay. Then, and so when we look for the x-intercept, we let y be 0. So when we look for the y-intercept, we let the other one, we let x be 0. Let x equal 0. So you take the exact same equation, but this time, where we have x, we're replacing it with 0, and then we got 4y equals a -12. So it was 2 times x plus 4y equals a -12. So 2 times 0, that's just 0. 4y equals a -12. So 4y equals a -12. And then dividing by 4, y equals a -3. So that would be the point 0, -3, which just means the y-intercept, therefore, is -3. Okay? When it's x, ordered pairs, x is written first. So it's x, y, so -6, 0. And then here, x, y, this would be 0, -3. Okay? We've got another problem here. Again, some of them involve graphing. These do not. Okay? So these I've got written on paper. The ones that involve the graph, I'll have to go to the computer for those. So it says find the slope and the y-intercept of the line y equals 1/4 x minus 7. So first off, this is already of the form y equals mx plus b. Okay? It's already of the form y equals mx plus b. That means m is the slope and b is the y-intercept. That's why it's called slope-intercept form. Y equals mx plus b is slope-intercept form. So in this case, it's already of this form. We just got to identify the slope, which is what's in front of the x, which is 1/4, and the y-intercept, is the -7. You do take the sign with it because it's understood to start off as y equals mx plus b. So if this is a negative right here or a minus here, that means b had to be negative. Okay? So slope is 1/4, y-intercept is -7. Okay? Moving on. This next one involves perfect squares again. Some may be, some may not be, but it's related to the square root of a rational perfect square. Now, this particular problem, I've got the square root of 27 over 48. I'm going to work it just like I did that last problem in lesson 7. I'm going to give the top its own radical, and I'm going to give the bottom its own radical. Okay? Because it's easier to work with them individually than to try to simplify a fraction dealing with square roots. Okay? Now, if this had been a perfect square, I would just have a basic whole number at the top. But however, 27 is not a perfect square. It may contain a perfect square, but it itself is not. So what I want to do is factor 27 in a way that I can see its largest perfect square factor. So 27, there aren't a bunch of ways to factor it. What you've got 1 and 27, of course, 9 and 3, and that's all I have, 9 and 3. So that's what I'm using. So I'm factoring 27 as 9 times 3. And I'm going to factor 48 as well, because 48 itself is not a perfect square either. And you might be wondering, how do I know that it's not a perfect square? Well, when you take the square root of it, if you don't get a whole number, then that means it's not a perfect square. Same thing with 48. If I don't get a whole number when I take the square root of it, it's not a perfect square. So 48 is not a perfect square either, but it does contain a perfect square. Okay, one of its factors, or I can factor it in a way to where I see the largest perfect square factor it has, or that it contains. Now, 48, I have options here. 48 is an even number. You can start off with 2. Okay, 2 and 24. Neither of those are perfect squares. So I'm going to keep going. I'm going to say 48 divided by 4. Well, 4 is a perfect square, but 12 is still divisible by 4, so that means there's something bigger than 4. There's a larger perfect square, even bigger than 4. So I got 2 and 24. I've got 4 and 12. Let's go the next perfect square. After 4, what we'd have 9. 9 doesn't work. After 9, we'd have 16. There it is, 16 and 3. 16 is the largest perfect square factor of 48. So I'm going to factor 48 as 16 and 3. Remember, you want the largest perfect square factor that you see. That way you don't have to simplify it more than once. Okay, because if I was to factor this in a way like 4 and 12, and then I broke the 4 down, I would have to still do the 12 as well. I have to keep going. But with me starting out with the largest perfect square factor, I'm able to simplify that and I shouldn't have to do it but once. So let's see what we have here. Now, I'm going to say, well, the square root of 9 and the square root of 3 on top over the square root of 16 and the square root of 3 on bottom. So basically, I just gave, just like I broke the top and bottom separate, I gave them their own radical. The product, I gave each part of the product, I gave each one of those factors its own radical on top and on bottom. So that way, the square root of 9, that comes out as just 3. And then I have times the square root of 3. And there's no reason to put the symbol in between there. I can just say 3 square root of 3. It's understood to be multiplication. Over the square root of 16, that comes out as 4. And I got the square root of 3 again. Well, the square root of 3 cancels with the square root of 3. That factor cancels with that factor, so I'm left with 3/4. Okay? I will get another one of these. I feel like I might need to work on more of these. Let's see if I got another one here. How about, let me try to make one up. Let's see here. Let's say, and it says simplify again. Let's say we got the square root of, let's say, I struggle trying to make up numbers. Let's do 72. I might should put the 72 on bottom over we'll make up a number. Let's go 108. Let's just go with that. Okay. So I'm going to give top its own radical. We'll give bottom its own radical. Okay. So we've got the square root of 72. 72 is not a perfect square, but it does contain a perfect square factor. So how do I find that? What I tend to do is I just start with, if it's an even number, I tend to start with 2, but otherwise I just start with the perfect squares. I'll divide it by 4, 9, 16, 25, 36, 49, 64, 81. Like I'll just start dividing numbers by the perfect square factors or by the perfect squares and see which one is a factor. Now with 72 being even, I even sometimes will start with 2. Even though I know 2 is not a perfect square, it might actually, when I divide by 2, it might give me one of the perfect squares as the other factor. So I tend to start with 2 when I'm dealing with an even number. So 72 divided by 2, actually, that gives me 36, which is the perfect square factor. So that is a perfect factorization that I'm going to use, 36 and 2. Okay. Now, sure, 8 would have went into it, 9 would have gone into it, but I'm looking for the largest perfect square factor because you got to simplify it completely. Simplify it all the way. All right, then I'm going to go to 108. Now, 108, again, it's an even number. Let's see what divides into it. I tend to start with 2. So 2 and 54. 54 is not a perfect square. Let's go on to 4. 4 and 27 works, but 27 still has a perfect square. It still has a perfect square factor, okay? I'm going to go with, I'm going to keep going. Let's go 108 divided by 16. That doesn't work. Let's go 108. 25 won't go, I know. Let's go 36. There it is, 3 and 36. So this actually is going to be a little different than the previous one, but that's okay. It's because I made it up. That's why it doesn't work out exactly the same, but the process is the same. You look for perfect square factors, you found it, okay? Now, the square root of 36 comes out as 6, and I keep the radical 2. And of course, I can break each one apart, give 36 its own radical. That's where I got the 6. Give 2 its own radical. And that's why I still got radical 2. And I'm going to do the same thing with this on the bottom. Square root of 36 comes out as 6. And I got square root of 3 still under the radical because 3 is not a perfect square and 2 is not a perfect square. They stay under the radical. So the 6's cancel out this time. And my answer is just square root of 2 over square root of 3, which I can just write as square root of 2 over 3. And that would be your answer. Okay? So again, you just have to practice. Think about the perfect square factors. If these numbers are not perfect squares themselves, they will contain a perfect square factor. You want to look for the biggest perfect square factor that will go into it. So again, while 72 is divisible by 9, I knew it was something bigger. It was 36. You want the biggest perfect square factor of that number because you want to simplify it as far down as you can. Okay? Here's something else. It says square roots of perfect squares with signs. So it says evaluate the following. Click on not a real number if applicable. Now, as long as, so first off, let me say this. This is a square root, and I should have said this before. This is a square root symbol when there is no other index here. When there's no number there, it's automatically understood to be a square root symbol. So as long as the negative is not under the square root symbol, you can actually just bring it right over and then just take the square root of 25, and that's just 5. Now, you cannot take even roots of negative numbers. So this square is an even root. You can't take the square root of a negative number. We cannot take the square root of an even number. Okay, So this would be not a real number. And if you ever weren't sure, check your calculator. Select or press second x squared for the root symbol. Enter in the negative symbol right here, not the subtraction. And then type 121 and then press enter. And it says non-real answers. Okay? Because you cannot take the square root of a negative number. We cannot take the square root of, I didn't say even, I meant negative numbers. Well, I said even. You cannot take the square root of negative numbers. Okay? All right, let's move on here. This is another one. This time, I want you to notice that it's a different index here. It's an actual index shown. That's a cube root. This is a cube root. This is a fourth root. This is odd. This is even. 4 is even, 3 is odd. You can take the odd roots of negative numbers. Let me show you how we can just whip that right in the calculator. So the cube root symbol, you're going to press the math key, and then you see it right there at number 4. So I'm going to go down to that. And then I'm going to enter in negative 125. And remember, I use the negative sign, not the subtraction. And I apologize for my calculator being kind of dingy. So cube root of negative 125, we get a negative 5. So in other words, negative 5 to the third power, we get negative 125. Okay? That's what basically we're saying. When we raise negative 5 to the third power, we would get negative 125. So the cube root of negative 125 is negative 5. Okay? Let's look at this one, fourth root. Notice that the negative is out front, which is just fine. As long as the negative is out front and not under the radical, we can do it. Just bring the negative over, and then you're going to take the fourth root of 256. If the negative was under the radical, you could not do this one. It would be no real number, okay? Because you cannot take a negative. You can't take an even root of a negative. 4 is an even root, okay? So this time I'm going to put the negative out front, and then I'm going to go math, and then I'm going to select number 5 here. And, let me put negative, and then I have to tell the calculator that my root is a 4. So I'm putting the 4, and then I'm going to go math like that, okay? I don't want the negative out front. Let me do this. Let me go negative, and let me go parentheses, and then press math. Let me go 4, and then press math. Okay, so what I needed to do, because I did not want the calculator to put the negative up there with the root, this is how I'm doing this. Okay, so let me just carry the negative over. Just ignore the negative and just carry it over. For the fourth root, you have to press 4 on your calculator first, and then you go math, and then you're going to go to number 5 where it has a little X in the index. That means you're telling the calculator what the index is. Okay, so I'm selecting that. And notice that it put the 4 in the index for me. Okay, I just carried over the negative sign because the calculator wasn't understanding that I'm not making the index negative. I was just putting the negative out front. So rather than try to, figure out how to put it in or use parentheses, just carry the negative over, okay? And then take the fourth root of 256, and that would be 4, but then the negative sign just carried over, so negative 4, okay? That would have been easier than trying to put that in parentheses and all that. So again, you type whatever the root is going to be. Let's say 4, then you press math, and then you go to number 5, and you're telling the calculator that this is the fourth root of 256. Okay? Moving on here, let's look at this one. Same similar situation. You're dealing with a perfect fourth root, but you got a variable on it. The variable, you're just going to treat it as if you're taking the exponent of the variable and you're going to divide it by 4. That's all we're doing. So I'm going to say 256. I'm going to take the fourth root of that. Okay. I am going to put that, since it's numerical, I can put that in the calculator. But with the variable part, instead of writing this as, I'm going to write it like this for now, but instead of keeping that as the fourth root of w to the 12th, we're going to write that as w to the 12th divided by 4. Because what that root means is when I write it as an exponent, it's meaning 1/4 power. Okay, so in other words, you take the exponent that's on your variable and you divide it by the root. Okay, so we had w to the 12th, so it's w to the 12th divided by 4, the fourth root of w to the 12th. So this 256, fourth root of 256, that's just 4. And then w to the 12th divided by 4, that becomes w to the 3rd. Okay. Let's see what else we have here. Look at this one. It's just basically what I just showed you, but where it's coming from. This says converting between radical form and exponent form. So this is a exponent form, and we're told to write it as a radical. This is 14 to the 1/6 power. That's the same thing as the 6th root of 14. Okay. So that 1/6 exponent can be written as a radical. It's a root, a 6th root. Like let's say you had 7. No, let's say you had cube root of 7. That could be written as 7 to the 1/3 power, going from radical to exponent. This one we're going from exponent to radical. If you had, let's say, 25 to the 1/5 power, that would be the 5th root of 25. Okay. So you can go from radical form to exponent form. Okay. It can take you either direction. This one we started out with an exponent. We wrote it as a radical. This one we went from a radical to an exponent. And same thing here. Okay. Let's see, a couple more here, and then we'll be done. This one, we're asked to evaluate it. You can plug it in your calculator as you see it, or you can express it as a radical. 81 to the 1/4 power is the same thing as the fourth root of 81. Fourth root of 81. And so a fourth root of 81, if you press math, or if you were to type it in exactly how you see it, 81 raised to the 1/4 power, that gives you 3. Or you can say math. Well, you got to actually tell the calculator it's a fourth root, then say math, fourth root of 81, same thing, 3. Here, 343, I'm doing the little house top here for the exponent, raised to the 1/3 power. That gives me 7. So I could also say cube root of 343. That would be the same thing. Okay? All right. One more problem here, and then I'll be done with this lesson. And of course, if you have questions about it, we can go over it in class on Thursday. But this one, it says simplify. You got the square root of 28, x to the 12th. So we've got the square root of 28, and I've got the square root of x to the 12th. Okay? So the x to the 12th is going to act like an exponent. I'm going to change that root to an exponent for that variable. But as far as the number, I would ask myself, is 28 a perfect square? 28 is not a perfect square, but it can factor in a way that I see a factor that is a perfect square. How about we factor it as 4 and 7? Okay, and then how about we change that x to be x to the 12th divided by 2? And it's a 2 because there's no index shown, which automatically means it's a square root or a index of 2. So I'm dividing that 12 by 2. All right. Now, 28 is not a perfect square, but if I factor it as 4 and 7, 4 is a perfect square. So the square root of 4 is going to come out as 2, and I got square root of 7 still. And then x to the 12th divided by 2 is now x to the 6th. So I'm going to bring that x to the 6th up front since it's not under the radical. I'm going to write it next to the 2. So 2x to the 6 square root of 7. Okay? Let's see if I can think of one more here. Similar to that. Let's go with, how about 32 x to the 16. So square root of 32 x to the 16. So I'm going to write 32 with its own radical, and I'm going to write x to the 16th with its own radical. Okay? Now, the 32 is not a perfect square, but it should factor in a way that I can pull out the largest perfect square that I can. So I'm going to say 32 divided by 4. Okay, that's 8. 8 is still has a factor of 4 as well. So that means 32 divided by 16 is the best way to factor, 16 and 2. So 16 times 2, because remember you want to factor it so that you see the largest perfect square factor that it has. 16 is the largest perfect square factor of 32. And then as far as the variable, I'm going to write that as x to the 16th divided by 2, because that square root can be written as a rational exponent. Now, the square root of 16 comes out as 4, and I still got the radical 2, and x to the 16th over 2 becomes x to the 8th. And I'm going to write that 8, or that x to the 8th beside the 4, and then I got the radical 2 at the end. Okay? That wraps up lesson 8. Again, there were a few more with graphing, but if you have any questions, I'll go over that first on Thursday before we look at anything else. And anything else you have on lesson 8, I'll go over that before we start looking at lesson 9. We are getting to the end. Hang in there. See you soon.